N5 tutorial section 16 looks at volumes of pyramids, cones and spheres. So the volume of a pyramid, which will be given to you, is 1/3 of the area of the base times the height. For a cone, it's 1/3 pi r squared h, where h is the height of the cone. And for a sphere, it's 4/3 pi r cubed, where r is the radius of the sphere. Now, quite often these questions will come up with a composite shape, so that might be a sphere or a hemisphere connected to a cone. Quite often as well they'll come up in a non-calculator paper, so you need to be able to apply simple arithmetic when the numbers are convenient enough not to use a calculator. And often the question will involve rounding to significant figures. Sometimes the question might give you the volume and ask you to work backwards to find out, for example, the height of the shape or the radius of the shape, so we'll look at that as well. Okay, so we're going to find the volume of this composite shape, which consists, as you can see, of a hemisphere and a cone. So we're going to split it into two bits, and first of all look at the volume of the hemisphere. Now if you think about the volume of a sphere being 4/3 pi r cubed, the volume of a hemisphere is half of that, and half of 4/3 pi r cubed is 2/3 pi r cubed. We can see clearly that the radius of the hemisphere is 4 centimeters, and we can use the pi button of 3.14 for pi, so that's 2/3 times 3.14 times 4 cubed. To two decimal places, that will give me 133.97 cubic centimeters. That's the volume of the cone, the hemisphere. I'm now going to look for the volume of the cone. Volume of a cone is 1/3 pi r squared h. So that's 1/3 times 3.14 times the radius squared. Well, the radius of the hemisphere also acts as the radius of the cone, times 4 squared, multiplied by the height. Now just be careful with this, it's quite easy at this juncture to put in the height being 10. The height of the full shape is 10, but the height of the cone, as you can see, is not 10. So the height of the cone is from here to here. Well, if the radius is 4 here, it must be 4 here. So 4 from 10 means that the height of the cone is given by 6 centimeters. So put that into the calculator. That will give me 100.48 cubic centimeters. To find the total volume, I then just add both them together. So 100.48 plus 133.97. 8 plus 7 is 15, 5 down carry 1, 4 plus 9 is 13, plus 1 is 14, 4 down carry 1, that's 431, and 134.45 cubic centimetres. Now if, for example, the question says to round to 3 significant figures, the answer would be 134. If, for example, the question was to round to 2 significant figures, it would be 130, and so on, cubic centimetres. Second one we're going to look at is to find the volume of this square base pyramid. So the volume of the pyramid is given by 1/3 times the area of the base times the height of the pyramid. We're going to do this one without a calculator. So 1/3 of the area of the base, well, the area of the base, it's a square, so length and breadth are both 8, and the area would be given by 64 multiplied by the height, which is 20. So we're going to do 64 times 20 and then divide our answer by 3. So 64 times 20, I can split that up, multiply it by 10 to get 640, and then multiply that by 2 to get 1280. I'm then dividing that by 3. So 3 into 1 doesn't go, carry the 1 over. 3 into 12 goes 4, 3 into 8 goes 2, remainder 2. 3 into 20 goes 6, remainder 2. So we're just going to extend that on, generate the decimal point. So 3 into 20 goes 6, remainder 2 again, and that's going to repeat. So let's say the question said to round to one decimal place. That would be 426.7 cubic centimetres. Okay, question 3, a little bit different. This time we've got a hemisphere. Now, rather than being asked to find the volume of the hemisphere, I'm given the volume of the hemisphere, but I need to work backwards to find its radius. We'll remember that the volume of a sphere is 4/3 pi r cubed. So the volume of a hemisphere then is 2/3 pi r cubed, and I know that that's equal to 250. So I can now use a strategy of changing the subject of the formula to r to work out the radius. So r cubed will be equal to 250, and bring all of this down, divided by 2/3 pi. To find r, it's then going to be the cube root of 250 over 2/3 pi. And to one decimal place, that is 4.9 centimetres.